Hi, I'm Dion from leavingcertmathsvideos.com. For the first part of this question, we know the first step, step 1, assume true for n equal to k, but we're already given it in k. So step 1 in this situation would be prove true for n equal to k plus 1. In this case, n equal to k plus 1. So then we have to prove true for k plus 1 all to be squared is greater than 2 times k plus 1 plus 1. So that is prove that k squared plus 2k plus 1 is greater than 2k plus 3. And what we do here is we can subtract 2k from both sides, and that leaves us with k squared is greater than, and we can subtract 2k from both sides and subtract 1 from both sides, is greater than 2. And that is true for any value of k greater than or equal to 4. So we'll be using this now in the second part of this problem. So here we also have to prove that 2 to the power n is greater than or equal to n squared. Now for step 1 in this situation, we have to assume true for n equal to k. And that implies that 2 to the power of k is greater than or equal to k squared. Now, what we also want to do here, it just comes in apparent later on. We just double both these terms here. So if the left hand side is greater than the right hand side, then obviously twice the left hand side is still greater than the right hand side. So that implies 2 to the power of k plus 1 is greater than or equal to 2k squared. Now, step 2. Prove true for n equal to k plus 1. For n equal to k plus 1. So that is 2 to the power of k plus 1 is greater than or equal to k plus 1 all to be squared. And that implies that 2 to the power of k plus 1 is greater than or equal to k squared plus 2k plus 1. Now we also know that 2 to the power of k plus 1 is greater than or equal to 2k. So if we replace this with 2k and we find out that 2k squared is greater than this term, then that implies that 2k plus 1 is greater than 2k squared. Then 2 to the power of k plus 1 is greater than this term. So I'll just write that down and say A is greater than B is greater than C, and that implies A is greater than C. So that's effectively what I'm doing here. So I'm just going to replace the 2 to the power of k plus 1 with 2k squared. So 2k squared is greater than or equal to k squared plus 2k plus 1. And if we subtract k squared from both sides, that implies k squared is greater than or equal to 2k plus 1. And that is true from part 1. We already worked that out from part 1. And we're actually not finished yet. We have to show true for n equal to of a certain value. So this will be our step 3. Now, any value greater than 4 is okay here. So that implies 4 squared is greater than or equal to 2 times 4 plus 1. That implies that 16 is greater than or equal to 9. And that's true. Right, so that implies that it's true for n equal to 4. And therefore that implies that if we've proven that it's true for one term, it's true for the next term. So if it's true for n equal to 4, that implies it's true for n equal to 5. And so on and so forth. It's true for n equal to 5, it's true for n equal to 6, so and all other values.
The real numbers.
Alright. If you found this video useful, please add me on Facebook or Twitter or subscribe to my YouTube channel. Thank you.